Hi, this is Mrs. Finnegan, and what I'm going to do is I'm going to show you how to work through problem number 32 on the pre-calculus semester 2 final exam review. So number 32 is solving an inequality. Notice as a quadratic because I have x squared. So I have 3x squared minus 4x is greater than or equal to 4. So there's a couple things we want to do. First off, we need to figure out where it's going to cross the x-axis. So in order to do that, we're going to move everything to the same side and solve it as if it was a quadratic equation. So when I move everything over to the left-hand side, I want to keep x squared positive if possible. It makes factoring easier. I get 3x squared minus 4x minus 4 is greater than or equal to 0. So I'm going to change that into an equation now so that I can solve it and find where my x-intercepts are, my roots. Now that I have it as an equation, okay, so now I have it written as a quadratic equation, so we want to factor it. So remember when we're factoring quadratic equations that whenever you have a lead coefficient, such as I have with the 3, we have to follow a special process in order to do that. So first I'm going to multiply first term and my last term together, which gives me a negative 12x squared. Okay, so then I'm going to list out the factors of 12x squared that would give me, or the factors of negative 12x squared, and then I'm going to find the ones that give me a negative 4 in the middle. So I have 1 and 12, 1x and 12x. That doesn't combine to give me negative 4. I have 2 and 6. That does combine to give me a 4. Just for the sake of showing you all of them, I have 3 and 4. That would combine together to give me a 1. Now to get a minus 4, I have to have 2 minus 6. So I'm going to use a positive 2x and a negative 6x. Okay, so what I'm going to do is I'm going to rewrite my equation, and I'm going to split apart the middle term so that it is, instead of minus 4x, it's now 2x minus 6x. Okay, so I have my equation rewritten out, and what I'm going to do now is I'm going to, just to point out, it doesn't really matter which order you put those two factors in, as long as you replace the original middle term with the 2 that would combine to give you that. So now what I'm going to do is I'm going to group together the first 2 terms and take out what the first 2 terms have in common. So what I'm going to do is I'm going to group these together and group these 2 together. So if I look at my first 2 terms, I have 3x squared plus 2x. I can remove an x. And then what stays inside my parentheses is going to be whatever is left over after I divide by x. So then now I'm going to look at my second 2 terms. Notice they're both negative, so I can take out a negative, and they're both divisible by 2, so I'm going to take out a minus 2. And if I divide each term by negative 2, negative 6 divided by 2 is going to be 3x, and then negative 4 divided by 2 is going to be plus 2. Oops, there we go. And that still equals 0. So now I hope you can see that inside my parentheses I have the same factor, which is 3x squared. So that's going to come out as a common factor, and I will put it up front. Whatever was ready on the outside is going to be its own factor, so x minus 2 is my second factor, and that's going to be equal to 0. So you can see over here on the left that I've gone ahead and factored 3x squared minus 4x minus 4 to 3x plus 2 times x minus 2. So now since I have 2 factors, I can set each factor equal to 0. So 3x plus 2 equals to 0, x minus 2 equals to 0, and these are going to give me my 2 places where I'm going to cross the x-axis. So if I solve 3x plus 2 equals 0, I'm going to first subtract 2. So I get 3x equals negative 2, then I'm going to divide by 3. So I find that one of my zeros, or x-intercepts, is going to happen at x equals negative 2/3. So that would be a solution to the equation. And since it is greater than or equal to in my original inequality, that would be part of my solution to my inequality, and we'll come back to that in a minute. For my second factor, x minus 2, I'm going to find that x equals positive 2. Alright, so now what I'm going to do is I'm going to set up a number line to help me determine which side of these zeros the rest of my solutions are going to be on. Okay, so on this number line, I'm going to mark where my two solutions are, and I'm going to put a nice closed circle because I know I can equal those two values. But I don't know, are the rest of my answers in between the two numbers, or are they on the outside of those two numbers? So what I need to do, there's several ways to do this, and so I'm going to show you the method that I like. I have three regions, region 1, 2, and 3, and what I'm going to do is I'm going to pick a number from each region and plug it back into my inequality and see which ones give me true statements. A true statement means that my solutions exist in that region. A false statement means that the solution does not exist in that region. I know that there's other ways you can do where you can tell if things are positive or negative, and so if that's the method you use, by all means continue to use that method. So in region 1, my intercept was at negative 2/3, so I'm going to pick a point at negative 1. So that's in region 1. In region 2, I'm going to pick 0 because that's the nice, easy value to use because it's between the 2 points. And in the region 3, I'm going to pick something bigger than 2. 3 is the next number bigger than 2 that would be easy to use. All right, so what I'm going to do is I'm going to insert these into, it doesn't really matter which inequality you use, I'm going to insert it back into the original inequality. So I'm going to take negative 1 and plug it in for x in my original inequality. So I would get 3 times negative 1 squared minus 4 times negative 1 is greater than or equal to 4. And now I'm going to simplify the left-hand side to see if it's true. Alright, so don't forget that when you square a negative, it becomes positive. So this becomes 3. Negative times negative is plus 4, so 3 plus 4 is greater than 4. Hopefully you are okay with the fact that 7 is greater than 4. So I get a big check for region 1. So region 1 is checked. That means I have solution in region 1. Okay? So now I'm pretty confident about what I know the answers are going to be for the next regions, but let's go ahead and test it out. So for region 2, I'm going to plug in 0. Okay, so I've plugged in 0, and that gives my left-hand side equal to, simplifies to 0. So 0 greater than or equal to 4. Hopefully you will be with me when I say no, that is wrong, so that's false. So region 2, I do not have any solution in. So now I'm going to do the same with region 3. I'm going to plug in 3 for x. Alright, so I've plugged in 3. 3 squared times 3 is going to be 27. Minus 12 is going to be greater than or equal to 4. 27 minus 12 is going to be 15, which is greater than or equal to 4, so that's a check. So that means I have a solution in region 3. So I can see my solutions do not exist between my two intercepts, but they do exist outside. There's two ways that we can write our solution. We can either write it as an inequality. We can say that x is going to be less than or equal to negative 2/3. Or x is greater than or equal to 2. Okay, so that's how you would write it as an inequality. If you wanted to write it in interval notation, alright, so as an inequality we would go from negative infinity to negative 2/3, and we can equal 2/3, so we would use a bracket. Then we have a union with the next set, which would be 2 to infinity, and since we can equal 2, we would use a bracket there. So those are that's your solution either as an interval notation or an inequality notation.